This is Eric Steinhardt, and I am here to tell you about the second edition of More Precisely, The Math You Need to Do Philosophy. It's a mathematics book for philosophers. This is the second edition, published by Broadview Press. You can get it from broadviewpress.com. You can, of course, buy it on Amazon, and you can learn more about it at my website, www.ericsteinhardt.com. The first chapter deals with set theory. It talks about sets and members, subsets, set algebra, power sets, pure sets, sets and numbers, ordered pairs, Cartesian products, the iterative hierarchy of sets. Second chapter deals with relations, talks about reflexivity, symmetry, transitivity, equivalence relations and classes, closures of relations, recursive definitions, and ancestrals. It illustrates a lot of these concepts using examples from personal persistence, including fission and closure. It talks about order relations, illustrates other relational concepts with the degrees of perfection arguments. In theology, it talks about functions, isomorphism, mental representation, cardinality, sets and classes. Then turn to machines, including finite state machines, which are used in the philosophy of mind. We also talk about the game of life and cellular automata, which are used in philosophy of science and physics. We talk about constructing the game of life from pure sets. Talks about Turing machines, and discusses how we can use cellular automata as models for possible worlds and the fine-tuning argument. Then we turn to semantics, where we talk about reference and how general terms refer to sets of things, one-world semantics. We then turn to more complicated semantic structures, including possible worlds semantics and possible world semantics with counterparts. From semantics, we turn to probability. We look at various issues in probability: basic probability, conditional probabilities, Bayes' theorem, subjective probability functions, Bayesian confirmation theory, and knowledge and the flow of information. That leads us to information theory, where the book discusses communication and coding, information flowing through a channel, compression using Huffman codes, then entropy, which is used in a variety of branches of philosophy, such as aesthetics. We talk about joint probability, joint entropy, mutual information, and then turn to some uses of information theory in philosophy of mind, such as mutual information and mental representation, and end the chapter with a discussion of integrated information theory and consciousness. Then we get to game theory, where we talk about a little bit of decision theory, agents and actions, act utilitarianism, expected utility. Game theory, now proper, talking about static games, then multiplayer games like The Prisoner's Dilemma, the Stag Hunt, talk about Nash equilibria, the evolution of cooperation, including The Prisoner's Dilemma, the iterated and spatialized iterated versions of The Prisoner's Dilemma, and how cooperation emerges in those contexts. We talk about public goods games and games in cooperation. Then I turn to infinity and move from the finite to the infinite, talking about recursively defined series and structures and the limits of recursively defined series and structures, such as the series of von Neumann numbers, the way that Achilles runs on the Zeno racetrack, the Royce map discussed by Josiah Royce, the Hilbert paper, an endless series of degrees of perfection arguments. Then we turn to infinity and infinite complexity, illustrated by the Hilbert Hotel, operations on infinite sequences, and finally ending this chapter with supertasks, such as reading a book described by Borges, the Thomson lamp, and finally infinitely powerful computers. We talk about the way Zeus performs a supercomputation and accelerating Turing machines, which can take the limits of infinite sequences of computations. The last chapter in the book deals with bigger infinities, that is, uncountable infinities and beyond. Talks about ways to compare the sizes of sets, ordinal and cardinal numbers. Then Cantor's diagonal argument, Cantor's power set argument, and the Aleph and Beth numbers, transfinite recursion, and ends with an application in theology. That is, more precisely, the second edition, again available from Broadview Press, from Amazon, and of course, you can learn more about it at my website, ericsteinhardt.com.